All right, so maybe we could go a little more in depth now. At the beginning of the screen or the top of the screen, I can see three tabs: Start, Settings, and Results. Could you maybe explain what those are?
Yeah, the Start tab is the welcome screen with a beautiful photo from Paraguay with various land uses and even some forest fires in the background. And below that, there's some basic information. Most of it I already explained to you in the first clip. So maybe now more interesting for you is the middle one, the Settings tab.
All right, that definitely seems to have a lot of new things. So at the top, I can see the time span. So what does that actually mean?
In the time span, you can set the years, the time period which you want to simulate, for which you want to compute the carbon implications of land use scenarios. For example, in this default case, the time span is from 2020 to 2100, so a period of 80 years.
All right. What about the options below the time span?
Maybe it's better that I will explain about these things later when we have looked at the results in the next clip. And after that, we can go back to the settings for more advanced users.
Okay, that's fine. Now below the time span, I can see three tables. If we go through them table by table, the first one seems to have two columns. What are they?
These two columns are the land uses, forest and cropland. For both of these land uses, there's one column, and then below those names, there's information related to that land use.
Okay, and these land uses are just defaults though.
Yeah, this is the default case. When you first open the software, this is the default case which will appear, unless you get the software from a colleague who has used it. Then it will, because CarboScen saves the last session of the user. Therefore, you could have different numbers here. But anyway, if you get it from the CIFOR website, these are the numbers that you will see.
All right. So on the left, I can see five different rows. So if we go through them row by row, the first one is land area at the end of the first year.
Yeah, that's right. Yeah, like it says, it's about area. So hectares or square kilometers or whatever is your unit. In this default simple example, I haven't been using actual units of area, but proportion of the total land area. Forest 0.2 means that 20% of the total landscape, which is simulated here, was forest at the beginning, or will be forest in the beginning of the simulated period, and 80% of the area will be cropland.
All right. What about the biomass carbon density at equilibrium?
Yeah, this is now a key row to understand what kind of values should be entered here. By the way, you can enter any values by double-clicking cell, and then by entering any value you wish to have there. But let's now go back to the default 100. So the biomass carbon density at equilibrium is, for each land use, there is this carbon density towards which it approaches year by year, and this carbon density at equilibrium value is set based on normally studies conducted locally. In this case, for example, it's 100 for forest, and for cropland it's 5.
All right, and then soil carbon density.
Yeah, that's the same carbon density concept, but for soil, for soil organic carbon, and here the default values are different, of course, and you could go down to 30 centimeters or 1 meter, whichever depth you want to use, but of course you should be consistent.
All right, and the last two are transitional speeds, so for biomass and soil carbon.
Yeah, these are the rates at which carbon in biomass or soil, the rates at which the carbon densities change towards the equilibrium values. So for example, in the case of forest, biomass transition speed is 0.03, meaning that of the difference towards the equilibrium value 100, if there is a successional forest going towards 100, but it's not yet there, it's for example close to 5 if it recently was a cropland, then 3% of the remaining change happens annually. So in this case, if it used to be a cropland very recently, the change is nearly 100 from 5 to 100. So roughly 3 tons of carbon, if that's the unit used here, is added every year. And the same in the case of soil. Just the settings here, the input values are different.
Okay. Well, if we go on to the next table, I can see there's a time span at the top again, but it seems to be different than the first time span.
Yeah, this time span is shorter than the top time span, and actually this top time span, the 80 years, were divided into these 2 time spans. There's the top land use change matrix for the first 30 years and the bottom matrix for the remaining 50 years. And yeah.
Well, what about the matrix in the first table?
Yeah, you can see that again, the columns have the land uses. Crop stands for cropland and for forest. But the same land uses appear here in the left in the titles of the rows. And each cell, for example, this cell in the top right sets the speed of land use change from cropland to forest land. There are 2 cells which in this case with 2 land uses, they always have the value 0 because there's no point in entering any other value for land use change from forest into forest. And this cell could have a value greater than 0, but in this default simulation it's assumed that there's no deforestation. There's no changes from forest into cropland.
All right. Well, what about the last table?
Yeah, that's almost the same thing. It's an identical table, just the time span is different. So again, but here the default settings are all 0, meaning that there's no reforestation, there's no deforestation. The proportions of land uses remain the same during this time span.